Hey, so chameleons are actually really weird, and I just learned 3 things about them that I want to share with you guys. First, chameleons actually have bones inside their tongue. That's right, the springy, snappy tongue, elastic, actually has a bone inside it. Take a look at this.
Did you see it? Here's a better picture. Now this one is super visible. And also this clip.
So why do they need to have bone inside their tongue? It's actually called a highway bone. We humans have it too, it's the jaw part, but chameleons' version are highly specialized to help them spit out their tongue super fast. Here's how it works. Alright, imagine this is a chameleon tongue. This straw would be the highway bone we just talked about, and the red part is the tongue muscle which covers the entire thing. When a chameleon's mouth is closed, the tongue is packed up like this. And if it sees a prey and is ready to shoot out its tongue to catch it, the front part, which is the accelerator muscle, will squeeze onto the highway bone really fast, and it will shoot out at an acceleration that's faster than even of a sports car. You know how when you squeeze onto a soap, it just shoots out of your hand? That is exactly the same thing, but just in reverse. Alright, the second thing I want to share with you guys is chameleons don't actually change color to blend in. Like, what? That just goes against all depiction of chameleon in mass media and everything I know. In truth, chameleon actually change color to stand out. Here's how it works. When the chameleon is calm, it's actually green, and to blend in with the surrounding trees and leaf. But when it sees a female or a rival male encroaching on its territory, it will start changing color. This is for them to get noticed. So how do chameleons change color? For the longest time, we thought chameleons change color just like all the other animals we know that change color, like the octopus or the squid. They have a cell called the Chromatophores, which contain yellow and red pigment cells. Then the cell can expand and contract. That causes the color change.
Here's a close-up of a giant squid chromatophores at work. You can see the cells expand and contract.
However, when scientists looked at chameleon skin under a microscope, they only found red and yellow pigment, but chameleons are green. So there must be some secret to their green color. Turns out, besides the chromatophore, chameleons actually have these tiny crystals aligned perfectly under the pigment cells. And these crystals reflect different colors of light depending on the alignment and the spaces between each of them. When the gap of these crystals are big, it reflects longer wavelength like the red light. And when the gap closes, it starts reflecting lower length wavelength light, starting with yellow to green and then eventually to blue.
Here's a view of the chameleon skin under the microscope. You can see the color changing action in the sequence we just talked about.
Now you have these 2 layers of reflection. The first is the pigment cell, which reflect yellow light, and the lower cell, which reflect blue light. Blue plus yellow is green, basic color theory, and that is how chameleons reflect green light. This theory is further proven by scientists when they looked at 2 chameleons, one calm in green color and one excited in yellow, and under a microscope, the crystal alignment matches exactly of what we learned before.
And if you press onto a chameleon skin, it will actually turn blue as you are compressing those crystals.
Alright, the last weird things I want to share with you guys. Chameleon actually glows in the dark when you shine a UV light on them. Take a look at this.
They glow in the dark because of the bone underneath, which are called the tubercles, and are covered by a thin layer of skin penetrable by light.
So why do chameleons need to glow in the dark when they already have all these color changes? First, we have to understand how heavily they rely on eyesight. Their eyes can move independently to survey the surroundings to spot predators, and they use their eye to locate the prey. On top of that, all their color changes rely on eyes to be able to see them to communicate. But on top of all this, chameleon can actually see way more than we do. Humans can only see the visible range of light from red to purple, but chameleons can actually see the ultraviolet portion of the light, which are way over here.
So while we can only see these glows under UV light, chameleon can actually see it all the time, and each of them has a different configuration to their tubercles, kind of like a handshake or a street sign.
And researchers have found that these tubercles are much more prominent on males than females. So the guess is that these tubercles are used along with the color change to make them even more noticeable to the females and the rival males.
And for a while, we thought chameleons are the only reptiles with glowy bones. But then we found this pumpkin frog, which also have bone that glows in the dark. Scientists are not sure why these frogs got their bone glowing. The guess is that they use it to warn off predators, which some can also see them under natural light. But when it comes to dodging predators, probably none is better than the super tiny chameleon, described just a couple weeks ago at the size of a fingertip. Scientists believe that they have evolved this small to be even better at evading predators.
Alright, that's it. Those are the 3 things I learned about chameleons and how cool and weird they are, and now you know them too. As always, remember to stay wild and stay curious. I'll see you next time. In truth, here's how it works. When the crystals are lined up perfect, and when the crystals are lined up in, so there has to be some secret. The secret is chameleon.